the energies can be in form of waves and also in the form of the matter. If you observe this world, the mobile signals, the sounds of the animals, birds, these all form a wave. But if you see this marker, whiteboard, this is all made up of matter. If I say the cup of the tea that is in front of you right now, it is not made up of matter, but it is made up of waves. The tea in it is also a wave, and the biscuits that you dip in it is also a wave. You will be surprised. But that is what the quantum mechanics tells us. A scientist in 1802, his name was Thomas Young. The scientist, he did an experiment famously known as the double slit experiment. Let us say that this is slit 1, this is slit 2, and this is the detector. From some point this passed through this slit, the one that hit here, they reflected and came back. The one who went to the slit went up to the detector from this slit and this slit. It was expected that at a point where they will hit the slit, a pattern will be created. Property of wave, which is unique only for the wave and not for the particles. That property of a wave is called inference. There is a constructive inference and there is a destructive inference. If two waves of similar wavelengths they come to each other, they form a constructive inference. While if two waves of opposite character they come together, they destroy each other. This is not found in the matters, it is only the property of the wave. So when he checked the results on this detector, he found out a wave-like pattern. The scientific community around the world was curious about this. They repeated this experiment by putting an eyepiece. They wanted to observe this experiment through their eyes. Just like the microscope that is in laboratory, in that there is an eyepiece through which you can see actually what is on the slide. Similarly, they put an eyepiece here. And the scientists observed through this eyepiece to actually see how the electrons behave. But as soon as the scientists saw through the eyepiece, the electrons started to behave like particles. Again, when the scientists stopped seeing through the eyepiece, they started behaving like waves. Schrödinger was the first scientist to give an equation to this quantum theory. This equation we call it as the Schrödinger's equation. So in this equation is about the smallest unit of a matter, that is called as atom. D square psi upon dx square plus d square psi upon dy square plus d square psi upon dz square plus 8 pi square m square h, that is the Planck's constant, multiplied by E minus V, where one is kinetic energy, other is potential energy. Psi is equal to 0. This is the Schrödinger's equation. Let us say that there is a box, and in that box there is one cat. There is also some substance that is poisonous in nature. Now, when the box is closed, nobody knows that the cat is alive or the cat is dead. But when someone will open the box, there will be only one possibility there. The cat will be either form alive or it will be form dead. This is known as the Schrödinger's cat. When you see the light, it is in the form of waves and there is no observer, it has limitless possibilities. Once the observer observes that wave, all the possibilities break down and only one fixed result remains. So this Schrödinger's cat, this thought experiment was analogy to describe the behavior of the light. All the wave functions they collapse and only one phase result remain, that wave function is described by this sign. X, this is the y, and this is the z. Now what this x, y, z is? Now Schrödinger said that there is a three-dimensional space around the nucleus where the possibility of finding the electrons is. He named this place as orbitals. So these x, y, z are the three dimensions that describe this three-dimensional space known as the orbitals. This x is nothing but principal quantum number, also denoted as n. This y is azimuthal quantum number, described as L, and z is the magnetic quantum number, denoted as m. So n, L, and m. Principal quantum number, azimuthal quantum number, and the magnetic quantum number. These are the three quantum numbers through which we can describe our orbital. Now let us understand what this principal quantum number is. Principal quantum number mainly describes the size of the orbital. n1, n2, n3. There is no n0. n1 is the place that is closest to the nucleus in the atom, and therefore it is the smallest in size. n2 is the next, and its size is larger. Similarly, the size increases as we go away from the nucleus. So this x or n describes the principal quantum number. This y, it describes the azimuthal quantum number. Azimuthal quantum number is the shape of this orbital. Azimuthal quantum number, if the orbital is S-shaped, the side is shaped circular. If it is P-shaped, it is dumbbell shaped. If it is D, it is double dumbbell shaped. So the size of the shape of this orbital, not size, shape of this orbital is described by the azimuthal quantum number, denoted as L. And third one is the magnetic quantum number. The magnetic quantum number is about the orientation of these orbitals in the space and the number of the orbitals. Now if it is s orbital, it is only 1 in number. P orbital, so the number of orbitals is described by the magnetic quantum number and its orientation in the space. So these three principal quantum number, azimuthal quantum number, and the magnetic quantum number, they describe a place around the nucleus known as orbital, which is three-dimensional shape. And because it is three-dimensional shape, we require three variables to describe it. This place is known as orbital, where the chances of finding the electrons are the highest. There is a very interesting phenomenon about the quantum mechanics. It is called as the quantum entanglement. Let us say that this is one particle. This green marker is one particle, and this is on the earth. This red marker is another particle, and it is like billions of light years away. This particle is on earth, and this particle is billion of light years away. Now I change something about this in this particle, something like I turn this particle upside down. Immediately, this particle that is billion of light years away, this will change itself. The information that needs to be traveled from this particle to this particle travels at the same instant. It not even the speed of the light. I am not talking about the speed of the light. It travels at the same instant.